Hello and welcome back to Little More Learning. And today we are back with our data analytics tutorial. And in this video, we will start with the basic data operations with Python using Pandas and NumPy. When we talk about Python's Pandas and NumPy, these libraries are essential tools for data manipulation, analysis, and basic data operations. So both these libraries integrate well, allowing efficient data handling in analytical workflows. While Pandas is ideal for structured data manipulation, NumPy is indispensable for performance-intensive mathematical tasks. Moving on, let's have a quick overview about Pandas and NumPy. So Pandas is known for its data structures, particularly data frame and series, which simplify handling and analyzing large datasets with tabular data. When we talk about NumPy, it offers powerful mathematical functions, particularly when we say it offers in arrays and matrix operations, allowing high performance calculations on large datasets. Now, let's move forward. So, we will start with working with NumPy arrays. So, NumPy arrays form basis of high-speed computation in Python. So, in this, we will learn how to set up, manipulate, and perform basic operations on NumPy arrays. Firstly, we should know how to create an array. So, we can create an array using this code snippet. So, when we are looking at this code, array equals np.array, and then we have given the elements. So, what it does, the output of this will be an array having the elements 1, 2, 3, 4, and 5. So, this creates a 1D array. And NumPy arrays are more efficient than Python list for numerical operations and provide vectorized operations. And when we move towards the next statement, this one, 0 arrays, and this is creating a 3 by 3 array of 0. That means it creates an array that is something like this, and then we have again a row of zeros, and lastly, because it is a 3 by 3 matrix, so we have 3 rows and 3 columns. Then ones array that creates a 2 by 4 array of ones. Now let's move on to the basic array operations. So NumPy allows element-wise operations, making it easy to apply mathematical transformations. So firstly, let's see an example of element-wise addition. We declare 2 arrays and then we add both of them. How do we obtain this result? It adds the corresponding elements of both the arrays and our results come to be 5, 7, and 9. Next, this statement calculates the square root of each of the element in array 1. That is, it calculates the square root of 1, 2, and 3 as the output array. Next comes up is calculates the exponential value of the elements in the array 2. Array reshaping and slicing. Array reshaping and slicing is useful for data transformation. So when we see this first statement, what does do? It creates a sequence and reshapes it into a 3 cross 3 matrix. It is useful for reorganizing data structures. So when we see this statement, so the output of this comes out to be, firstly we have first 3 elements, then we will have corresponding next 3 elements, and after that our last 3 elements. So this will be the output of this statement. Now when it comes to the slicing statement, it demonstrates NumPy's powerful slicing capabilities. It selects first 2 rows and columns from index 1 onwards. So what output it will give? It will give 2, 3, and next it will give 5, 6. So this will be the output of this particular statement for slicing the elements in a NumPy array. Now, introduction to Pandas. Like Panda offers 2 main data structures, that are series and data frames. Series are one-dimensional labeled arrays capable of holding any data type. And data frame is a 2D labeled data structure. You can consider it as a table that is ideal for storing and manipulating large data sets. So firstly, we should know how to create a series. So this statement creates a labeled array, or we can say a series with custom index labels. So the output of this would be A 10, B 20, C 30, D 40. And the data type for this will be an integer of 64 bytes. Now, if we have to create a data frame, what we should do, we should follow this code snippet. And for this, if we look at the output from this, we will obtain, firstly, we will have 3 columns named name, age, and city. The indexing here also starts with 0. So we have 3 names. So the indexing will be 0, 1, and 2. The names will be presented here. For this example, it will be Alice, Paul, and Catherine. Their respective ages 25, 30, and 35, and their cities New York, Los Angeles, and Chicago will be represented. So this is how a 2D data frame can be created using this code snippet in Python. Next, we have loading and exploring data with Pandas. The first step in any data analysis project is to load the data and understand it. So Panda provides you numerous methods for importing data from various sources and exploring its content. Suppose we have to load the data from a CSV file. So we will use this code snippet. And if we have to inspect the first few rows, we will use df.head. Now it shows the first 5 rows of your data frame. Very useful for quickly checking your data structure and content. And then we have summary statistics. What does do? It provides statistical summary of numerical columns. Suppose if we have age, so it will provide us the summary of count, how many people are there. It can provide us the mean of ages, and it can provide minimum, maximum, and if you want to calculate the 25% of amount or 50% of amount, then this summary statistics is very important. Next is data info. That is basically, it shows you the information about the columns, like if you want to know what the data type is, or if there are nulls, non-nulls, memory usage. These type of information and missing values can be found using df.info command. Next is data selection and filtering with Pandas. Filtering, selecting, and slicing data are essential for extracting relevant information. Like for selecting the column, we can use df name. It selects the name column. And if we have to select multiple columns, we can separate them by comma, and remember to use the single quotations for writing the column name. When it comes to filtering the rows, we can use conditions, and it is quite similar to what we used in SQL, just a basic syntax differences there. And then we have index-based selections with i.lock and lock. i.lock allows selection by index positions, while .loc selects based on labels. So if we use iloc, from this to this, the first 2 rows and the columns 2 to 3 are selected. And with LOC, if we use the column name and the value inside it, it selects the rows where the city is Chicago. So for handling missing data, we can detect the missing values using the isNull function. And if we want to drop them, we can use the drop any function. And if we have to fill them, we can replace them using 0 or fill any function. And this fill any function, what will do? It will simply replace the none values with 0. Basic data transformation. Panda offers many methods for transforming data, which is crucial in preparing datasets for analysis. So what we can have in data transformation is renaming column. It is important to make your data more descriptive, like name can be renamed to full name, city can be renamed to location. Adding and modifying columns, create new columns on modifying existing one is important. Like you can add the category to an employee, whether they are senior or junior based on their age. Grouping and aggregating the data. Group data based on a column and calculate aggregated values. It helps you to get statistical summary of your dataset. Merging and joining data frames. Combining datasets is often necessary in analytics. Pandas support merging and joining operations, which help create richer datasets for analysis. So, if we have to concatenate data frames, or we can say combine data frames either vertically or horizontally, we can do that using Pandas. So let's say we have two data frames named df1 and df2 and we concatenate them. So what do you think what will be the output of this concatenation? So the output of this concatenation will be a b 0 1 3 1 2 4 0 5 7 1 6 8. So this will be the output of this concatenation. Next is merging data frames. Data frames can be merged based on a common column. So this will be a task to find out that what will be the output of these lines of code when you merge two data frames. So that's it for today's video. And in the next video tomorrow, we will be learning about data cleaning and transformation using Python. And I hope you like this video. If you liked it, please like it and subscribe to the channel. Comment if you have any questions and don't forget to comment the answer of the last code snippets of merging the two data frames. And till then, happy learning. See you in the next video.